There are trillions of transactions that are happening on a daily basis, and there is a pretty much chance that you might be using MS SQL Server as a database management system in your applications. As a developer, you would have created tables, you would have inserted data into it, and you would have filtered and written data format. Have you ever wondered how the data that is getting stored or persisted is structured behind the scenes? If not, there is nothing wrong in it. But if you are curious how the data is structured, then you have come to the right place. First thing first, let's try to understand it from the theory perspective, and let's then execute some queries to actually relate to what we saw. The basic building block of the SQL Server is a page. So page is similar to a page in a book, wherein it has like the text information. Similarly, in SQL Server, they have a page. So what does the page contain? The page usually contains a header and rows. So what are these rows? Let's say we have a table called person, and we have the ID, and we have a name. So the first ID is Surya, second ID is Renu. So in this case, ID 1 and the Surya is gonna be part of the rows. So they call it as a row record within this page. Say this is page 1 and it has 2 records right now in here. So it has records 1 and 2. This is the first page and it has records 1 and 2. And this type of page wherein it has the actual information of the table data is called data page. So what else do we have? So we have index pages, we have GAMs, we have IAMs, keeps tracks of the allocation, one that tracks the free space and stuff like that. So there are different types of page. The other thing that we need to know is the index page. The index page is only applicable for the table that has a clustered index. So say if this is the cluster index, meaning like if it is a primary key, then it will have an index page, and this index page, say it's root index page, and the root index page will point to its sub indexes, which are intermediate indexes, and these intermediate indexes will then point to the actual node containing the data page. So to retrieve an information from the page, so it goes through the index and then it navigates through multiple levels in depth of intermediate indexes, and finally it reaches the data page. How they know where to go is based on the header. So the header has the object ID and the partition ID and also the index ID. Index ID is generally 0 for heap, 1 for a clustered index, and it could be greater than 2 for a non-clustered index. So the header contains the object ID, partition ID, index ID. The object ID here is the ID of the table itself. Say if it is the person probably will have a ID, say like 3, 4, 5, 6, and that will become the object IDs 3, 4, 5, 6. So let's come to the partition ID later. Typically how they store the data is in forms of 2 different trees. One is called Heap. The other type of tree in which they store the data is like B plus trees. So the heap stores the tables that does not have indexes, like the flat tables without any index. So if you have the index in the table, then the data of corresponding row will be stored in a page which will be in the form of B tree. It will have the root as index, and like it will have like a lot of intermediate indexes. The final leaf node would be the data page. That way it is a linked list in here, right? So then it could be easily sorted, and it will help to fetch the data faster. So this is how a typical seek operation will happen. Say if we are looking for the data at number 6, then it goes through 5 and then it goes through 6 and then fetches the data page for 6. Here is a table that I created earlier. This table has a primary key, which is the ID, and I have already inserted 1000 rows into this table. So what we are going to do now is let's execute this query. Once we execute this query, what we see here is we see each of these record, which is like the row record, has the page number listed, and it also has a slot within the page that it goes under. That's where it resides. So let's say if we scroll down here, so till 112, all those data above it reside in the page number 392, and like from 113 it goes into page number 701, and similarly it ends at page number 224, and then it starts at 225. The complete memory allocation is taken care by IAM, and it determines like when the page when it has to go to the next page. page and start writing into it, right? So that is totally taken care by it. The limit is like 8 KB, so at when it goes to the new page. So this is how we could determine where the record is within a page. So the next thing that we need to know is the extents. What is an extent? Extent is nothing but a collection of 8 pages. So you have a page in here with a row record, and like you have another page with a row record, and similarly you have 8 pages in here starting from 0, 1 to 7, right? So 8 pages, you have 8 pages, and this collective 8 pages are called as extents. In the same example that we discussed earlier in the person table, say if you have one more column called resume, wherein say if it clocks as varchar max, right, and you have more than 20,000 or 16,000 characters, right, in here. Say for example, I'm just putting an example in here. So when you have 16k characters, then what would happen is it would actually bounce out of memory of a single page. This page only can contain 8 KB of data, right? In which case the ID that we had, the first name and the last name, wouldn't take too much space, but the resume, which is about 16,000 characters, would take a lot of memory, and it would not fit into the same page. So it has to be put it into a different page, and there has to be a pointer to that page. So that's the reason they say, like, when you have large data which is like in the form of text, put it in a binary format if it is not mandatory to search on top of it. In which case, like, to retrieve the data, it has to go to a different page and merge it with the current page, and then it has to respond back when it is queried. So that's the reason it takes a little bit longer to query the actual data. As per the extents can be a combination of the same table, and also it could have a different table. Say when you get started with, you will have only less records, right? In which case it will have the 0th index as person table, maybe the first index as like the classroom table, and so on. But wherein when it sees the person table is growing, then that's when it decide all this 8 pages could go into a single extent. So that is completely taken care by the IAM. This query is going to provide extent IDs for the corresponding pages that we have. Here we have 8 pages that corresponds to the extent ID 49. We have 8 more pages that corresponds to the extent ID 87. If you see here, the first page is an index page in here, and the rest of the pages are data pages. Wherein in this case, page number 591 only has IAM page, which keeps track of the allocation maps, the row ID data and stuff like that. And if you see here, like, these are null pages, meaning they are not allocated. These are unallocated pages. When we add more rows to it, these pages get populated. When the rows gets populated into those pages, the IAM changes that to allocated. The next thing that we want to discuss is the partitions. When we create the table, there will be a partition assigned to it, and it will have an ID called partition ID. And the partition ID is 1-to-1 with the HOBT ID. So when a table gets created, it will also get a HOBT ID for it. The table ID will have an object ID, which we already saw. This does not talk about a partition that we use instead of group by. So that's a different thing. So this partition is where we split the table into multiple pieces. Say for example, when we store the historical data by year order, say if I want the records from the year 2021, then we can have a separate partition for the year 2021. If you want to fetch or update the records to the year 2022, then we can have the year 2022 as a separate partition. That way it executes the query only within that partition. To demonstrate that, we are gonna remove this and paste it here and execute it. So if you see here, this is the partition ID for the object, which is the person. The index is 1 since it's clustered, meaning it has a ID as primary key. We saw that earlier, right? This is the partition number, and we have the HOBT ID in here, and this is we have 1000 rows of records in here. And if we have specified any compression, then this has the information of it. Right now we do not have any compression on top of it, and that's the reason you see it as none. I have one more table wherein I have 5 partitions. Let me try to execute that. So if you see here in this table, we have got 5 partitions. So each of which has different rows. Like the first partition has 273 rows, and the second partition has 308 rows, and the third partition has 209 rows, and the last one has to 10, and I have the fifth one do not have any rows in it. The data has a range and it does not fall within the range, and that's why there is no data in it. And if you see here, like each partition has its own ID and it has a different HOBT ID as well. So a partition would be unique within the database. So the next thing that we are going to look into is the file and the file group. Let's first see what a file is. File is something similar to a book. A book has collection of pages. Now we have seen all about the pages. The file is nothing but the collection of, it's a collection of everything that we have in here. So there are three different types of file. One is the primary file, the secondary file, and the log transaction file, which is the third type of file. So this has extension .mdf, this has an extension .ndf, and this has the extension .ldf. So when we do not specify any file during the time of creation of a table, or when we alter it, then all the table goes to the primary MDF file. .mdf file. So all the tables that we create, if we do not specify any file, then it goes into MDF. Where does the file group come in? So these files can be collectively grouped together, can form like a RAID like structure, wherein different files can write into different disks. That way it could enhance the performance. That's where file group kicks in. So say if when we create a table, like we can specify which file group the table has to go into. It can probably go into two different file groups, or it can still stick with the same file group. This command throws out the list of files that we have in here. So if you see here, shell rows that goes in here, which is the primary file, and this is the third log file. I do not have a secondary file. Say if I want a secondary file, I probably would need to specify it while the time of creation of the table, or during the time of alter command. Similarly, we have the file group query that displays the file group information. So if you see here, like now we only have a primary file group. The last thing that we would need to know is the database. So let's run that query. This displays database ID of the current database that we are using. That's pretty much it for today's video. I have compiled all the queries that we executed today and put the information in the description box. Hope you have enjoyed it. Thanks for watching. See you in the next one.